Okay, good morning, good afternoon. Today we're going to be talking about computing in scientific notation, but now we're going to be multiplying and dividing. So 1.7, day 2. So here I just want to kind of show, if we have something like this being multiplied, we can actually just rearrange it a little bit. So we can do the 5 times the 8, and then we can do the x to the second times the x to the fourth. And then we add those, and then we do the y to the times the y, and this is our final answer. And that's kind of what we're going to be doing here. We're going to just rearrange them a little bit. So when we're multiplying, you want to first multiply the decimals in front of the powers of 10. You want to add the exponents on the powers of 10, and then write your final answer in scientific notation. So I do want to get a calculator out just to be prepared for those, because we're going to be multiplying, and I want to save some time with it, so I'm going to use a calculator to show the multiplication. Let me get this out here. So our first one, evaluate this. Now if you see that it's all multiplication, I can rearrange it because the order in multiplication does not matter. So I can multiply these two numbers here, so 7.2 times 1.6, multiply those. Then I can multiply the 10 to the third times 10 to the fourth. Okay, so our first step was multiply the decimal numbers, so 7.2 times 1.6. And I get 11.52. 11.52. That was my first step. Second step was add the exponents on the powers of 10. So remember, when you are multiplying like bases, you can add their exponents. So now this 10 to the third times 10 to the fourth becomes 10 to the seventh. Now the last thing is we need to write our final answer in scientific notation. This is not in scientific notation. Why not? Because I have two decimal places, or two numbers to the left of my decimal. So I need to make this decimal go to right there. So I want it to be 1.152. Now, I made 11.52 become 1.152. So I made this number smaller, so I need to make this number on the exponent bigger. So I move this one place, so I need to add 1 to that 7, and it becomes 8. Okay? Now, again, I'm multiplying. So I want to multiply my two decimals, so 2.63, 2.63 times 1.2, I get 3.156. 3.156, and I need to add these two numbers. Now 4 plus a negative 3, now I can check my answer here. 4 plus that negative 3, and I get 1. Oh, there we go. I should also think if I'm adding a negative, I'm actually just subtracting. So 4 minus 3 is 1. So it becomes times 10 to the first. Is this number in scientific notation? Yes, it is. So I'm done. This is my answer. Okay, here, 8.4. I'm going to do that math first. So 8.4 times 2.5. I get 21. So 21. And then I'm going to add that 2 and the 6, so it becomes times 10 to the 8th power. Am I finished? No, because my decimal right here, my invisible decimal, is right there, and I have to move it to right here so it has only one number before the decimal. So remember, I made 21 into 2.1. So I made this number smaller, so I have to, by one decimal, so I have to add 1 to the exponent. Okay, if I were to, this 21 times 10 to the 8th, if I were to write that in standard form, this number here, and then if I write this one in standard form, these two numbers would be the same number. And that's something, somehow you could check your answer that way too. Okay, dividing, again, this is kind of going to be the same, except now we're dividing the decimals in front of the powers of 10. Then you're going to subtract the exponents, and then you're going to write your answer in scientific notation. Okay, so again, I would get a calculator out, make it a little easier. Okay, so I'm going to do 8.37 divided by 2.7. I get 3.1. And then here I'm going to subtract the exponents, so it becomes 10. 8 minus 3 is 5. My answer is in scientific notation, so I am done. Okay, this one, 4.64 divided by 2.9. I get 1.6. Now, negative and a negative. Now, I have to write it like this. So negative 4, I need to subtract a negative 6. If I see both negatives here, I can actually add them. And negative plus a positive. So negative 4, I add $6, or 6, I like to think of it as money. Anyway, I add 6, I should get 2 left. Now, negative 4, I can also check it on my calculator. So negative, remember this right here is my negative sign. So negative 4 minus sign negative 6. I should get 2. And I should always check my answer if I'm not comfortable with adding and subtracting of those negative numbers. Okay? All right, in 2010, let me actually go here. We did this part already. All right. In 2010, the world population was about 6,860. Oh, wait, no, not 1,000. Billion, 6,860,000,000. Right? The population of the United States was about 3 times 10 to the, I want to say 8th. About how many times larger? So when you see how many times larger, that means that I'm going to divide my bigger number by this number to see how many times larger it is. Okay, so this number here is going to go on top. Right here. And I'm going to change it to, because it's such a big number, I want to change it to scientific notation. So remember our imaginary, well, that's a period right now. Now it's a decimal. My decimal is right here. I want it to go in between those first two numbers. So 6.86. Now, I'm making this number smaller, so I need to make this number bigger. I'm moving it 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 places. And then I also have to look here. 3 and times 10 to the 8. Now, remember how many times larger is the world population? The world population is going to go on top than the United States population on the bottom. Okay, again, I need to do my 6.86 divided by 3. I get 2.286, and then I'm repeating. So it's going to be 2.286. I'm going to put a repeating sign, and I should put an equal sign, times, and then here, 10, and subtract my exponents, so 10 to the first power. Now, this, here we go. Okay, so 22, now if I were to move this decimal, or, oh, sorry. If I were to actually write this out, times 10 to the first power, in standard form, this would be 22.86 repeating, right? Now this is standard form, and it's asking about how many times larger. So I want to round this number, and that's where we get that 23. It's going to be 23 times larger. That's where we got this information here, 23 times larger. All right, the surface area. Surface area of Lake Superior, the largest of the Great Lakes, is 8 times 10 to the 4th square kilometers. And the surface area of the smallest Great Lake, Ontario, is 18,160 square kilometers. About how many times as great is the area covered by Lake Superior than Lake Ontario? So this one is my bigger one. So 8 times 10 to the 4th divided by, here I want to make this scientific notation. So 1.8, remember my invisible decimals right here. I need to move it to 1.816. So 1, 2, 3, 4. So it's times 10 to the 4th power. Now, is it a negative or a positive? So this number, we're making it smaller, so this becomes bigger. It's going to be a bigger number, so it's correct. Here I need to do 8 divided by 1.816, and I get 4.405. Lots of numbers, so equals, let's see that, 4.405286344. Okay, and now times 10 to the 4 minus 4, 0 power. Now, if we remember, anything to the 0 power is 1, so I wouldn't actually have to write that, but I'm going to, because I want to. All right. Your assignment is page 63, 1 through 7 odd, number 13, 19, and 23. Remember, in a separate sheet of paper.